Good morning. Morning. Hi, I'm Marco. I'm one of the 5 people left on the planet that still wears a mask. Um, I'm sorry for this. It just has to stay this way because next week I have an appointment, so I can't catch it this week. That's the only reason. Sorry. So I'm gonna stick to this plan. Otherwise, I hope everyone can hear me right. Is that okay? Right. Effectively, today we're talking about event sourcing. Who already knows something about event sourcing in general? Who has never heard of it? Never heard of it. Nice, cool. Okay, because in my opinion, event sourcing is really boring. Okay, that's my opinion, but I presented this talk like so many times in so many years. I think I started being really annoying about it in 2015. There's nothing new in event sourcing. It's something that is very common in the industry, and we are going to just explore how this works. Practically, what we do as software developers is we usually take some data and we save it in a database, and then we load it from the database, and we modify it and put it back in the database, and load it again and put it back in the database. Every time we do this, we lose data. Okay, so a bank doesn't work like that. A bank does not save the amount of money you have. A bank saves the transactions that you've done over the years. So they know how much money you have by calculating what you have done with your money, not by saving how much money is in your bank account. And the reason is that if you don't save all the transactions, well, first of all, you lose accountability, and then you may have rounding errors, you may have little problems, you may have like a write error somewhere, and you have a huge problem. So, event sourcing is basically moving from what we usually do as software developers, where we take a database and do an insert, an update, or delete, and instead we turn it into only inserts. There's only insert operations. So it's a bit of a more mature way of operating with our data. This is very common in more mature industries, but we as software developers, especially once databases started becoming more popular, right, like in the 70s or something like that, we had limited disk space. So because we have limited disk space, we try to operate with mutable data. We modify the data and we pull the rug under our users' feet because they are going to lose information. And now in the last years, developers figured out, oh, we have infinite resources, so let's set the planet on fire by burning all the resources. And they invented things like a blockchain that runs on hard drives, just because you can throw more hard drives on it. And effectively, the problem with disk space is no longer a problem. Who here has a company with more than 50 terabytes of database? Right? 1 terabytes. Right. That's 2 people. Okay. So if you here are like worried about scaling, don't worry about it, because I can run a 50 terabyte database in a single rack server in my basement. And that's okay. You don't need to go AWS, you don't need to go Lambda, you don't need to go big data, GraphQL, whatever stuff, right? You don't need to do any of that. Um, what I like to say to my customers is, when they tell me that they have big data, I ask them, is it more or less than this? And usually it's less than this, right? This is a 64 gigabyte USB stick. Most of my customers have less than a 1 gigabyte database sometime. And they still say we have scalability problems, right? Because they're convinced of it. It's just that you work with your data wrong. So let's go back to basics. Let's go back to what is the point of this stuff. So I'm gonna try and represent what we generally do. What did I do there? Whoa! Sorry, I haven't used the touchpad in ages, so I'm gonna have to relearn how to do it. So let's say that we have a general user flow. I am breaking everything. What's going on? Possible. Let's try that. Um, I think control was just stuck. Wait, shape. I didn't want shapes. I wanted a simple sticky note. How did I break it? Did I remove sticky notes from from Miro? I'm so good. And now I can no longer have sticky notes. Are you shitting me? I'm terrible at this. Right. Oh, there we go. Sticky notes. Thank you. Right. So let's build a piece of software that does an update operation. So we have a post endpoint register, right? And when I post to register, what I do is I go through my HTTP server, and then from my HTTP server, I get to some sort of framework somewhere. Don't really care about the framework stuff. This talk has no frameworks in it. But then from the framework, we keep going on, and then we talk. Usually, what happens is that who here uses Symfony, for example? Pretty much everyone. Then you go like to some sort of ORM doctrine or deball or whatever, and the ORM will then perform an insert operation in your database. And it will insert the data, and the data goes to your database. And now you have a different endpoint where, let's say, you want to see your own profile, right? So we do a second endpoint. Oh, you gave me a mouse. Sorry, I didn't even realize. I was too much in the zone. All right. Is this on? This is not on. Well, okay. So then we have get profile /123. So this is my other endpoint. And from profile 123, I go through my HTTP server again, and I go through my framework again. And then from the framework, I go down to the ORM or debug layer, whatever. And yeah, thank you. Excellent. Oh, that helps. Get or selects star from users where and blah, blah, blah. So this is effectively what every one of us does all the time, right? And we talk to the database. And this pretty much is how we operate. So now what happens is that if I want to change my profile and I create a new put, or well, let's say we do a patch request to /profile /123, and now I go through the entire chain again, and now down here I do update users set blah 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 where blah blah blah. So this is what we do when we update some records. And what is interesting down here is that we already lost some information. So whenever I change my profile, this is very black and white, by the way. I'm not sure if it's intentional or not. No. So this is what we typically do. So we have a scenario where we post and create data that leads to an insert operation. Then we have a get operation. That get operation reads from the database, and then we have a put or a patch operation, and we replace data in the database. This works fine. Most companies are okay with this. You don't need to overthink it. There are many business scenarios where this works pretty much okay. But first of all, every time you operate on a user, you don't know what their previous state was. So if they mess it up, you cannot help them, right? Typical scenario. I deleted a product from my e-commerce. Whoops, I deleted it, and now all our revenue is gone. Or maybe you performed a purchase and you can no longer make it retroactive and whatnot. So effectively, you lose the ability to know what happened. So now you start adding logs. So what usually happens in a scenario like this is that customers ask you to introduce either aggressive logging or auditing. One thing that every company at some point asked me to do is like, we want for every update and every delete to have some sort of log, some sort of audit. And that happens at a certain scale that they start doing complete audit trailing of everything. And that's a waste of time. So what we can instead do is we can take this entire flow here. I'm going to actually copy all of it. And we are going to remove everything down here. So we do our get, post, put. Sorry for anyone bothered by the lack of arrows and lack of alignment. Maybe it's just me. It just bothers me at least. Anyway, so what you can do is when you do an insert, you can push the information to something called an event store. So the insert part and we insert some information, but what we insert is more interesting. We insert stuff like an object called an event, new user registered. Okay, so we have a concept of new user registered. We have a concept of new demo subscription started, and we have a new user activated, let's say. And these are 3 events produced by your post interaction. So you produce them from here, and they all get inserted directly into a database. So what's weird about this is that we are no longer saving a user, we are saving what happened. So that stuff all goes into the event store. And then pretty much from there, we continue on. So now we have a post operation. What happened with the patch? Let's say that we have a patch operation. Patch operation would be, for example, new user added profile or added mailing address and user provided profile picture. So you still keep adding by doing inserts in the same structure. So that stuff keeps going down here and you keep pumping into it, right? So what happened is that you have a one giant table called this event store. You can call it event store, event stream, history, but it's the history of your system. So every state mutation is represented by an event. This works really well, but now how do we represent the get operation? Now I need my profile, right? Now I need to show the profile of my user. I don't care about the mouse battery, thank you. So the profile operation becomes a bit more complicated because now you have this flat table where there's like lots and lots of events that are kind of like sequential, one after the other. So what you can do is you have a separate operational database. This is called like, for example, I'm going to call it read model. We can call it read model, readdb. And the framework reads from here and does a select operation. So like kind of like before, we do a select from users. And it happens down here, but it's in a separate database. And in between here, you have pretty much a projection system which copies data across. So you have a kind of like a flow like this that synchronizes data and goes from the event store to the read model. Who uses Elasticsearch? 2, 3, a few people, okay? This is what you already do for Elasticsearch, right? So what you do is you take a product, you transform it into some JSON stuff, and then you throw it at Elasticsearch. This is also how caches work. So what we did is we took and we made our important stuff a list of events. And the list of events gets converted by a process into a usable database where you are more familiar with. So this could be a table, but it could literally be just the Elasticsearch index if you wanted. You could make an HTML page, like literally from here, generate HTML pages and pump them into a file tree. So you don't need a web server on this side. So what is good about this is that sometimes when you do this right, you can get rid of all this part, right? You can completely get rid of the framework, I know it's small, and the SQL operation because you have a data structure that already matches what you need. And what we call this entire thing, this entire box, this is CQRS and event sourcing. CQRS stands for Command Query Responsibility Segregation. So commands, left side, we modify our data. Everything that has to do with modifying data is basically on its own database, on its own data structures that are optimized just for modifying data. And the read operations are on their own database, on their own data structure, on their own dedicated system. It may look complicated, and it is for many use cases. If your application is CRUD, don't do this. It's a waste of time. Don't do it if you're just doing CRUD. But if you're not doing CRUD and you're doing advanced business logic, you're an insurance company, you're a bank, but even just like if you do an e-commerce, what you do is you insert like shopping cart, added item, removed item, added item, removed item, whatever. And then you have a shopping cart model that is the current state that you can read from. But your marketing team will be really happy to know every time a product got removed from the shopping cart because they want to know, why did that product get removed? Was it too expensive? Was there another product that was more interesting? So they often miss this sort of information. You got a question? Exactly. That's exactly what bookkeepers do. So we as software developers don't do it because we got used to just connecting to our database and replacing the data. But what you're supposed to do is you take and you do bookkeeping, and then at the end of the year, you go through your bookkeeping and you calculate how much taxes you need to pay, right? That's how it works. You don't have a number on which you pay your taxes. You have your invoices, you have your expenses, you go through them at the end of the year, and you calculate your taxes. You don't have a number that every time somebody gives you a receipt, you add a number somewhere. You don't do that. That's stupid. You're going to have a mistake somewhere. So don't do that. So that's literally all there is. So is this clear so far, what the concept is?
A question.
Yeah.
So this synchronization, it happens on every event created.
No, you decide when it happens. It has to happen, but it could be immediate. It could be once a month. It's your decision when you do it. You kind of do it when you need this, right?
Depending on when the read.
Right.
Okay.
So today we are going to write a lot of this, but effectively the base concept is CQRS is about separating the two databases. That's CQRS. And event sourcing is about representing state mutations as events. So we have 3.5 hours maybe, and we have lots of trying out stuff. So there's going to be a lot of code that is going to be written by you, or you can ignore it. That's also fine. So for that, I have prepared the workshop material. So you can go to this page. This is my event sourcing workshop on GitHub, and we want to clone this repository. So if you haven't done it already, let's go and clone that. And who doesn't have a laptop, please like sync up with somebody, because this is going to be a lot of coding and very little talking by me. I'm happy to answer questions, But my idea is to get you hands on the code and trying to figure out what's going on. So I'm gonna do the same as well. I'm gonna just try and clone the repository. And I'm going to clone this particular repository. I prefer cloning via Git, so I can then push. So, down here we have a README. And in the README, I endorse to fire it up. We're going to run some make commands. So the first one is make composer install. Which should pretty much pull the image, and you should be able to get something running. And yes, we are on Wi-Fi. If it doesn't work, I have USB sticks for everything. That is slow, by the way. That is quite slow. Well, this is taking a whole lot of time. I did not expect this to last this long. So there are another couple make commands that I endorse looking at in the README. There's make quality assurance, which will run every check on the repository. So while you try out stuff, run make quality assurance, and you will get a nice report of what you did wrong before you break it completely. Jesus, that takes long. Okay. So make quality assurance runs the tests. There are some tests. You don't need to worry about writing tests during this workshop. We can write tests, but I won't force it on you. And there's a bunch of other checks that are happening. So it's checking for a few things, like it's checking for type soundness of the project. I don't write PHP alone. I generally write PHP with Psalm nowadays. Changes how you write completely. And then it checks a couple other things, like did you put everything in the right directories? Who's got the installation done? Okay. So the entire project that you cloned is both a library and an example project for Eventsourcing. I tried to use as few libraries as possible to make it work. There's no frameworks involved. There's no excessive magic. We just keep it very, very type safe. So what we're going to use today is some PHP. We're going to use some functional PHP, and we're going to run everything on PHP 8.1. Well, some composer, you saw that. We don't add any other dependencies. SQL, very basic SQL. Make commands, you saw them, and Docker Compose, they happen behind the make commands. You don't need to worry about them, but that's like everything that should be running. If you have any problems setting it up, just let me know. Like if you're stuck on something, yeah. I'm super happy to improve on this. So the idea then is, first of all, is that we represent Yeah.
I think your mic is not working.
Yeah, true. Because I turned it off while helping
Yeah.
people. Sorry.
No problem.
So, anyway, it's all documented, and I try to make documentation files for everything. But let's start from the basics. So we discussed what event sourcing is, and event sourcing it is kind of like bookkeeping. So you save what happened instead of what is. So the building block of an event sourcing system is the domain event. So a domain event is a payload. It is a single immutable piece of data that you take and you save it in the database, and you can load it from the database. What is part of an event is a descriptive name. So it's not like a symphony event, you know, when you just like dispatch or whatever. It must have a very clear business related event, such as workshop started, workshop completed, conference started, conference keynote started, right? Payment initiated, payment completed, payment delayed, and so on. So they must be very, very clear, and they must be pertinent to what you are doing in that exact moment. So, for example, customer filed a complaint. Don't use abbreviations. Try being descriptive, and it should be to the past tense. So an event has a name. It describes what it is, and it's generally to the past tense. So it's something that happened. So when you look at it after instantiation, it already happened. An event must have the point in time at which it was raised. So that specific point in time must be part of the event. And an event has some contextual information. So there are some fields like who is part of this event, what did they do, etc., etc. So that is just some payload. But a good event tries to answer their 5 W's. So kind of like in investigative journalism, but journalism in general, you try to answer the 5 questions that are who, what, when, where, and why. So who is part of the context, what is the name of the event, when is the time, I said the time must be part of the event, where, again, context, and why sometimes it's not always possible to infer the why, you know, like temperature recorded, why? I mean, it's just temperature recorded, we don't necessarily know all the time. So, there are 2 ways of producing events. One way is to say like, okay, something happened in the real world. Like, somebody fined me. If somebody sends me a fine or somebody sends me something to pay, it just happened. I have no control over it. It's something that happened in the real world. The temperature increased, you can do whatever you want. You can't control the temperature. It's just how it is. Okay, so those are like kind of like standalone events. They just happened. So temperature recorded, email received, a day has passed. We will use a day has passed, for example, today. Those are kind of like standalone events. They happen on their own. You don't have control over them, or maybe you produce them and they just come from the outside world. And then we have things like mutations on top of your system. So if you have a shopping cart system, like you are managing an e-commerce, then the shopping cart, you can add items, remove items. You can also decide when an item got removed, because you know if the item was already in the cart. So you can decide, okay, you can't remove an item if you don't have it in your shopping cart. So those are more coming from processes that you have under your control, and we will see that later. That is the concept of aggregate. I'm not going too much into detail on aggregates, but that's the idea. Or shipment, shipment assembled, shipment shipped, shipment delivered, or shipment lost, for example. So to save an event, we have a table called an event stream. You can probably see a database. There is a data structure. And if you run make quality assurance, did you run make quality assurance? Right? If you run make quality assurance, you should have a database.sqlite here in the data structure. In the database. So if I open it, right? Then if you run something like PHP Storm, you can see what is in there. And here I'm going to just look at the tables. I know it's really small from there, but let's say that I go to the event stream table and I can pretty much see what's happening inside it. So this is a table with like a bunch of events in it. There's a number of the event, there's the type of the event, and then some other mumbo jumbo. But effectively, that's how you save an event. You insert it. I gave you an abstraction called the event store. I know it's a long namespace, but it's just event store. And what you can do is you can create an event and put it in the event store. So that's what we're going to do as the first exercise. So we have a directory called exercises. Go to exercise number 1. It's called record the temperature. And try running it. And what we need to achieve here is creating an event and saving it to the event store. So my endorsement is take the data directory, delete the database SQLite, and then run the script. Actually, I'm gonna use a terminal for this. So I'm going to exercises, exercise 01, and I'm going to run the exercise record temperature. This will complain about some stuff. And what we want to do is to get it to run. So this implies writing an event class. I left some notes in the exercise file, but write an event class and then save it in the event store. And I would give you around 10 minutes or so. Sorry? Oh, because you run the acceptance test, so it started adding some stuff to it. Yeah, so you don't, you run the script, it recreates the database on its own. So I also printed the usage in the error message. This is how you're supposed to use it. So record temperature, and then we say a location like conference room, and then the temperature in floating point numbers. Well, Psalm will just tell you if something is obviously wrong. Let's say that it helps you, but sometimes it takes a lot of experience to go around Psalm. So take it more like a suggestion. There is a very good chance that if Psalm is complaining, that it also the exercise will not work. But that's just like a hint. So my endorsement is yes, get it to green, but you don't need to waste time on it. Like getting it to run is more important today. It's more like most people usually do very, very simple basic mistakes and they don't realize it, and Psalm really helps in that. Oh, this is a wrong tip. Sorry. I think it's just kernel event store. My bad. Is anybody not running or not seeing the database? Like, can you open it from your IDE? Does it work? Okay. This is going too smooth. I'm suspicious. Half the people are not doing the exercises. So the interface for a domain event is really, really minimal. It just has this interface. It must contain arrays that, and you must be able to convert it to an array and back. So I don't like this. This is not really part of an event. That's not the interface, but for now this works well enough for this workshop. If you never open a SQLite file from PHP Storm or from IntelliJ or from whichever editor you're using, it may actually ask you to download a SQLite driver. for JDBC. So if you get an error like I can't find schemas or I can't open the file, close it again, close the database, or remove it entirely from the side and reopen it. So something like this, you just is a dangerous word, but you can like say remove here, right? And I'm gonna confirm that I removed it, and then I can open it again. Oh yeah, well maybe if I run something, let me actually rerun it. So now the database should be here. Oh, I broke it. I broke it entirely. Oh yeah, no, never mind. Room 123. Let me try again. There we go. Database is again here. And now I open it, and down here there's a download button. Now there's an update button, but for me it works, so I don't trust doing upgrades during a workshop. And now you should have the database on the side. Okay. You had a solution, right? Okay, so who's got it running? Okay, need help? Yeah. I literally drew a repository that I wrote from scratch and nobody ever saw. Yeah. Are you on your phone? Make interactive shell. Right. If you get a syntax error, that's probably because you're running from your host, and we are using everything from PHP 8.1. Like this project uses all the fancy stuff from 8.1 already. Okay, let's type it together here. I'm gonna start writing the exercise from my end. So we have this record temperature and we want to get it working. So what I'm going to do is I'm going to make a new branch first of all, because everyone needs to be on the same page. Exercise 01, recording temperature. Okay, so we need to write a new temperature recorded event, and it needs to be somewhere under source temperature tracking domain. Source temperature tracking domain. I'm just gonna drop it here. Don't really care about more stuff. Okay, this is namespace. What is it? Event sourcing workshop. Temperature tracking. No, we don't want exercise in it. Final class temperature recorded. Implements domain event. So we're implementing this domain event. One thing, domain events are immutable. And so you should probably use this. If you run make acceptance, Psalm will complain about a bunch of stuff. So I'm just gonna show you how that looks like. This is make quality assurance, or actually make static analysis I'm gonna run. And now Psalm will complain and it will tell me that I did not implement an interface. Right? So it says I did not implement the methods from this interface. And this class is also unused. So in general, during the workshop, you can run make static analysis or make quality assurance. It will give you some idea of how broken your examples are. It should be fine, but it will help you. Okay, so I'm gonna implement, whoops. I'm going to implement everything from this interface, and we're going to add a constructor, public function construct. For anyone who already followed other workshops of mine, I gave up on named constructors during workshops because it's just too much information. So I'm going to add a public read-only string location. And I'm also going to say that's not a non-empty string. That's just me being more precise. I like being extremely precise on my type. So if something is a never empty type, I prefer to describe it explicitly. And a public float, I don't know, Celsius. So far, so good. Our object doesn't do much. Now what we need to do is we need to also add a time at which it was raised. Public read-only date, time, immutable, raise that. So, as for the implementation, well, raise that just returns our time. Sadly, interfaces don't allow for properties or even read-only properties. I would really love to have read-only properties on interfaces because effectively this object does not have behavior. It's only a bunch of data. It doesn't do anything. And then we are going to return the entire serialized payload of this object. So this is where maybe your implementation and mine will differ a bit, but I'm just going to show you my implementation here, and then you'll see the difference immediately. So I'm going to get the location, which is just a string. I'm going to say Celsius. Also here, Celsius, I used a floating point number. Maybe you may want to use a value object. So you can say this is a Celsius object, and this is, I don't know, a Fahrenheit temperature, and this is a Kelvin temperature. You know, Kelvin temperature cannot go below 0. You know, it's just an example. It doesn't exist. So you can enforce that at domain level. And then the raise that. This is probably where most people haven't done this. And I'm going to format it as date, time, immutable. I like this format. It has microseconds in it. So this is kind of like how events look like for the most part of this workshop. So it's a bunch of fields. We just save them, and a bunch of fields returned into array and erase that. And most of it will be like this. I like making everything public because we have immutability enforced by Psalm, and because read-only helps us as well. It's really hard to modify stuff. So now we have this object. Now we want to use it, right? I'm gonna run the static analysis command again. Takes a bit. I should probably remove the no cache. So now it's just complaining that the class is unused, but everything looks fine in our class. It's just complaining that it's not used. I'm gonna use it, and I'm gonna go to the exercise page. So in the kernel, we have an event store, which you can use. So going to the kernel, I'm just gonna check what is this event store, and it's a SQLite event store. And what it does is you give it a bunch of events, and for each one of these events, it will insert it into the event store. Nothing special happening. So it's just like saving the class of the event. This is something we can argue, you know, like the name of a class in PHP is wonky. Everyone hates those double backslashes in database. You may want to translate it here, whatever, but I wrote a very simple solution that just saves the class name. And then you get erase that and the payload, which is just JSON encoded event to array. A bunch of these functions, if you ask, they come from a library called PSL, which is awesome, and which just takes the PHP core functions and makes them usable. Like a lot of PHP core functions have really janky, complex, weird details that come from C or decades of backwards compatibility that nobody cares about. So that's literally all that happens, right? Is that's not a difficult class to grasp, right? It just like does a save and loops over objects and turns them into stuff in the event stream.
Locating the raise that in the payload.
Yes, and that's because I did not bother writing a complex deserializer. So I take everything that is in the payload and I put it back in the object from the payload. So it's a bit janky on that side. Practically, it would be possible. So practically, if I were to write this with maybe another week of time, I would get rid of toArray completely and instead do something like use a serializer to serialize the fields, because all of these are visible. You don't need to write logic for them, right? You don't need this. This is just because I did not bother making you install something like JMS serializer and then having people debug why does JMS serializer not work, because it would be just too much time. So in other languages, this would be serde or infer serializable or so on. So we add our event here. So I'm gonna say new temperature recorded and pass it the location, which we already have. I extracted it from here. Did anybody already write code like this before? You ever see this? So this is another interesting concept of this PSL library. You can build the types and then use them to transform inputs into well-typed structures. So if you run Psalm and you say Psalm trace and you tell it what is the temperature, and I'm gonna just like comment this for a moment and run it again. So Psalm trace will tell me what the type of that temperature is, and it will understand that temperature is a floating point number. And it can do that because we built a structure that is well typed, and we said key 1 must be a string, key 2 must be a floating point number. In my case, non-empty string, because I said location. Actually, let me show you how it fails first. But this allows me to build a well-typed structure out of literally garbage, because this is just an array, right? I don't know what's coming out of this. I'm going to save the temperature recorded. We save a location, we save the temperature, and we take the kernel clock now. So this is equivalent to new date time immutable. That's the same exact thing. It's just that if you write it this way, instead of writing it with new date time immutable, you can now write better tests and you can simulate the clock. So if I were to have a production bug in which at the specific date the script fails, I can now take the clock, change it, right? Rerun the script frozen at that point in time and observe the bug. Whereas if you write new datetime immutable, you have to change the system clock of your Linux system. And that's way more complicated. So this is just to make sure the clock is potentially frozen. So we created the event, we raised the event, now we save the event, and now we want to run the script. Or I'm gonna run this script from exercises, exercise 01, record temperature, conference room, and this is 32.1 degree. That's really hot for a conference room. You don't want to be conferencing there. So what happened? Nothing actually happened, but what happened in our data store? If we go to our database, we see that there's a bunch of tables. Some are from Doctrine. That's just like Doctrine tracking what are the projections. Oh, sorry, what are the tables that got created? And then there's this event stream. And the event stream, I'm gonna transpose the data. Can I? Is there no view transpose? Where did they move it? No? The annoying things of event sourcing is that once you wrote the events and they're in the event store, the cat is out of the bag. You cannot change those events. So if you remove a field or if you change the definition of a field, that doesn't work. So while event sourcing is cool, you cannot say that suddenly customer registered is an event that requires another 5 additional fields. It doesn't work like that. So this is one of the big pitfalls of event sourcing, which is you need to be extremely careful to nail down the event before deploying. There are mitigation strategies, but it's really hard. So one of the attendees had a problem now, which is that for my event, it is called Celsius. The temperature is called Celsius. And for him, the temperature is recorded as temperature. So now his event cannot be loaded because the field name is different. Okay? That's perfectly normal. My suggestion is start from my branch and delete the database again. That's good enough. We don't need to like make it super complicated. But this is normal in event sourcing. You cannot deploy new event definitions with changed stuff. It's really difficult. It's kind of like an API backward compatibility, but inside your database. Valinor? Oh, Valinor does that magically. That's the magic stuff. So one thing that happened for you is that I call this Celsius, and I called it Celsius here, and for you it's called temperature.
Where I could tweak my...
No, don't go there.
Okay.
Lots of work to make that work. Valinor, if you look at actually where Valinor is configured, it's in the kernel. In the kernel, I create the mapper. That's it. There's no other config. So you can try being smart. You could like do something like register constructor, and you say function array data, for example, to temperature recorded. Right, something like that. That's something you could do perhaps. Why FN? Sorry. Yeah, something like that maybe would work, but it's difficult to make it work. Don't go there. There's an entire documentation about Valinor. This Valinor thing is just literally creating data out of garbage. You give it a mixed and it tries to figure out, okay, what did you want from this mixed? Okay, you wanted an event. Okay, I'm gonna try making it. But if something doesn't match up, it will fail. Yep. Gonna write a bit of the solution just to make it clear what we need to do. So we need to do something like for each kernel, where is it? Traverse event stream with some stuff, just the last temperatures. That's the name as event, and here you do something. The name that you pass here is just the name of your iterator, and we'll get to that later. I'll explain why. Anyone manage a solution? Yeah, let's go latch it. Pointers, ideas. This also uses kind of like Psalms, more advanced generic types. So you see this is returning an iterable of the main events. So you get a list of the main events. You need to iterate over them. They're already deserialized in your data store from your data store in memory. Oh yeah, I did not optimize it for M1. It's a bit slow.
Oh, it's not even M1. It's
Uh, Anyone you have a solution? Why? Yeah. Question was every time I run this, it no longer iterates over everything, and that's by design. Look at the description of the traverse event stream interface. So effectively, what it does is something like this: it iterates. So it says for e equals get last index, so it will start from an index that is the last thing it saw, and then it will iterate over everything that it did see only after that index, and it will save the last thing it reached. So it's an iterator, but the counter stays persistent. There is a table in the database. It's called event stream cursors, and actually, let me run it. I'm just gonna run the exercises, exercise 02, right? It will complain, but here it should have an iterator now. So you see it has a 4 here. What you can do is you can delete a row from the database, and it will start from scratch if you need to. Otherwise, just pick a different name every time you run it. It's good enough. Go here first. In theory, this should be a fixed name. So when you run it again, what happens? Like, is it correct if you run it like that? I can tell you it's by design. Just new events every time, because you don't. Let's say you have 1 million events. You don't want to start from scratch every time, right? Oh, you can just use different names. Okay. It's by design that it does not read. So the reason why it doesn't restart from scratch. Did you raise the volume? Okay, it's weird. Okay. The reason why it doesn't restart from scratch every time is that if you have an event store with 1 million events or 1 billion events, you don't want to start from 0 every time, right? What happened, it happened. You don't need to look at it again. You already have the temperatures for last year. You don't need to go through last year, okay? So that's the idea. That's why you say like 2020, 2021, what happened, happened. I don't care. Like, just give me the new stuff. So that's why this iterator does not start from scratch every time, but it keeps a counter inside. So that's the, where is it? This interface. That's why we keep a counter, and that's why we save the point in time at which we were last time. Okay? Yeah. What happens if you run it in a
Yeah, I get the
empty file?
The empty file. Yeah, it just overwrites with the empty array.
Yep. Okay, give you another 5 or so. Actually, no, I'm gonna start writing because it's 10 minutes that we have until break. And then, so let me go ahead and start writing it. So, we have, well, first of all, new branch. Exercise 02, track last temperatures. Okay, so we are looping over this data structure. We discussed that we don't want to loop from scratch every time. So when we run this loop, every time we run it, it will continue from where it last left off. So temperatures is for now an empty array. I'm going to define that this is an array of non-empty string to floating point. I like defining my types up front so that the tooling then assists me with like saying, oh, you're pushing some garbage into it. I'm going to say if not, the event is an instance of, what was it, temperature recorded? I'm going to continue. I don't care. Otherwise, temperatures of event location is equal event temperature. Oh, Celsius, sorry. And now we're going to write the file. I like putting it into the data directory. Last temperatures .json with JSON encode of the temperatures. Another thing I would add here, I'll add a git ignore last temperatures JSON. We don't want that to be committed. So far so good. I'm gonna just try it, and obviously you'll tell me what's going on. So project last, actually I need to record some temperatures, right? So I'm gonna record a few temperatures. Conference room should be 32.2. Balcony, it's 45, something like that. Hot summer. So now I have my events, and actually I'm gonna add a var dump here so we can see it doing stuff. Event, right? I'm gonna run the exercise again, exercise 2. So you see it's dumping some actual objects. We know that it's a temperature that was recorded. So we have the event data, and we are just going to extract that and look at what it produced. Cat, or actually JQ data. Wait, is there not a, or I don't know how to bash, sorry. Yeah, no, it's fine. It's just, ooh, let's just cat it. There we go. So it's saying conference room 32, balcony 45. But then what happens is if I run the script again, and it's gonna empty my structure, right? Because there's no temperatures again, because it didn't loop from the start. So the point here is you need to remember that whatever you project, you are responsible for starting from the right point in time. And that's just to understand the concepts behind it. So I'm going to say that the temperatures is equal, well, if file exists, if the file exists with the path to the data directory. Where is it? Last temperatures. Then I'm going to populate the temperatures. Is equal JSON decode file get contents. I don't need to save the library, sorry. File get contents with dear data last temperatures JSON. Okay. And run it again. Well, now I need to clear the cursor, right? The one that I've shown you. I'm gonna delete this row from the database, upload it again. I know this is all a lot of stuff to discover on your own. Okay, don't worry. If you're like, holy crap, Marco, how am I even supposed to know all this? Don't worry. I know it's a lot. It's a 4 hours workshop with materials for 20 hours. So, I'm gonna project again. And now we have cat data last temperatures, and we have it again. I'm running it again, and there it is. Okay. So what we want effectively is for it to work. But if I now do make acceptance, and this is just make quality assurance, sorry. If I run it, it will complain about a bunch of stuff, and that's because it will say, look, you're putting apples into oranges, right? Because it says this is a mixed assignment. And this is just a different way in which I work, in which I make everything like as painful as possible, so the types must match up. So Psalm is saying, look, I don't know what this is mixed, because you're just like throwing a JSON decode to some variable that you say is something else. And now we're trying to work with this mixed object. The interesting part is that this library, this PSL library, has a JSON structure that allows us to work a bit better. So PSL JSON typed. So I can, instead of just running garbage through it, I can take the JSON, which is PSL file, I think read, yeah. So I'm going to read the data, and I have to give it a structure. So this is the type in which I want this to be deserialized. So temperatures is equal to PSL type shape, or actually it's a dictionary, right? And it goes from PSL type non-empty string is the key to PSL type float as the value. Make sense? I know it's a bit of a complicated thing as a start, but it's just showing you that there are better things than JSON decode for working, you know? Like, you don't need to do JSON decode stuff when there's better libraries that do better things for you. And I'm gonna try it again, and it will be wrong to some degree somewhere. Right, tell me it runs, tell me it's okay. Yeah, okay, that's fine. I mean, it will complain about coding standards, but yeah. We have 1 minute left. So What do you complain about now? Whatever. So, effectively what we did is we loaded the temperatures in memory. We then traverse the event stream, produce a data structure that is useful to us for our use case, and then we put it back in the file, okay? And we get a file like this. So we have coffee break now. How much time? 20 minutes coffee break. I'm going to commit and prepare the branch, and we swap to the next exercise. So we're going to level up to yet another level, okay? Cool. Till 1 p.m. I still have 3 exercises to do, and one of them is a mess. So, okay, so what we did so far was, by the way, I pushed up a branch. It's this branch name here, feature exercise 02, track last temperatures. Hey guys out there, please quiet. Ah, holy shit, never mind. So effectively, what we did right so far, write it down, please. Please. What we wrote so far is what you would call a projector inside Eventsourcing. So, a projector is effectively an array reduce operation on top of a fixed set of items, that's like your event store, and an initial state. So, that's what projectors are. Nothing really fancy. We've gone through like the basics of it. You iterate over a list of domain events, right? And some initial state that we saw that needs to be the file that you already have, that is your initial state, plus the position at which you were. And the fact that an event in an event source system, you can base yourself on the assumption that whatever was in the past is in the past, and you don't need to look at it again. You can effectively work with this kind of construct in a relatively stable way. So what you can do is you can go a bit more crazy, and you can have multiple projectors. So what I like to do inside my event source systems, and this is really up to you, it doesn't need to be done in a specific way, but what is important is that you have a definition of how a projection works and a way to run it. So in the first exercise we did, it was just a script. So this script would be like this, where is it? Project last temperature. This is our definition of the projector. It's simple enough, but when you go a bit more complicated and you start having a lot of projectors, what you would like to probably have is a definition and a clear definition of where the data goes to, so usually a database table or something like that, and a system to run this. So you can use Symfony Messenger, you can use RabbitMQ, although RabbitMQ is not super safe. You can use Kafka, you can use a DB table trigger. You don't need to do it outside the database. You're super good with SQL, just do it with SQL. You don't need to go out of the database. Because a projector is really just this operation. So you can do it with any programming language that can do it. You want to write it in a different language because it's more efficient than PHP, do it there. So we take the event stream as a table. We have this projector that's kind of like our traverse stream stuff that we saw. And then a definition of a projector and a definition of a table, and run it. So let's go to exercise 3. So exercise 3, the idea is that we want to do the last thing that we did. Oh, we want to project the average temperature, not the last temperature. Okay. So we will have to add a database migration. I don't know if anybody has written database migrations before. There are examples in the repository. So I'm going to show you one. So this is how a database migration in Doctrine migration looks like. It's an up function with some SQL to be executed, and some down, which is just to roll back the migration. We will not roll back during the workshop because we can always delete the database. But in a production system, you need to be very, very careful about what you do in migrations. Anyway, so we will have to write a database migration that is a data structure that allows us to compute the average temperature for a specific location. And then we write a DB table projection definition, which will effectively tell us how to modify the data in the table. So I'm going to show you what the definition looks like. So a definition is you give it the table name and then a set of operations. So the operations are a list from a class. So you give it the class of the event and a function. What do I want to do with that event? So you receive the domain event, a table, and optionally a connection, and you implement it. I'm going to show you an example of that. So, for example, here, this is how you write it. So you have an event and a function, and the function does an upsert on the table in this case. So you have, for example, let's say table insert, ignore, you have table update, you have table delete, right? That's what you can do. Or you can work with a connection object. And you can do whatever you want here. Connection, run, or execute query, right? Execute statement. That's kind of what you're supposed to do. So write a migration, write one of these, and then we glue it together with this class that already exists in the project, which is effectively the same as this guy. Okay, so we are going to write a projection definition, a database table definition. So this is the migration, this is the projection definition, and this already exists. And in the exercise, there is already some sort of outline. So the idea is new process, or actually, where is it? Process projection definitions on table for definition, and we give it a new my table definition. And what we need to give it, the connection that comes from the kernel, and kernel traverse event stream. That's what we need to do. And the migration here. My migration class. So far so good. And down here is subtle run it. Right? We don't just create it, we also want to run it. So for understanding, this is kind of like a Symfony Messenger super light, kind of. That's the idea. For the SQL, keep it very simple. It's SQLite. It works with usually what you know. Nothing fancy. It's an average, right? You need to store the sum and the count of times you've seen a temperature, right? Again, for the migration, look at existing implementations. And same for the project and definition, look at existing implementations. Just remember, we can also use a connection. tough one. So who had the migration? Somewhere here, right? So you want a column with the count, a column with the total, maybe a column with the average. That's up to you. You also want the count, right? Yeah, how are you gonna compute the average temperature? I'm gonna start by writing the migration on my end. And so we want to write a migration, right? I'm going to create one. We have the namespace temperature tracking. I like keeping my migrations under infrastructure. Infrastructure, migration, average temperatures table. No, not exercise, just temperature tracking, please. Okay. So this add SQL. Why is it complaining? It's probably complaining because of this. All right. So now I can add some SQL stuff here, and I'm going to add create table projection average temperatures. And in here we need the location, text, primary key, or what was it, varchar? What other migrations do I have? Varchar is good, yeah. I don't remember varchar ever, like. It's such a pain, like you always go over this anyway. It's not null. Primary key. We want the total recorded or accumulated temperatures. What is this number? I don't remember this. Float. Let's just save a float, we don't care. Real. You can save a thing as real. Let's try real. And the recordings count. Actually, this is just not null, right? We don't insert it. And we do a average temperature, right? So now we have our table, and how to run this, you take this and you go here and you just add it to this method. That's kind of how it runs the migrations. So if I run examples, exercises 03 and I run it, it will complain. Oh, it must be an array, I forgot. Must be an array. I run it, and now I go to my database and I refresh the database. I should see my projection, right? That's going to give you a projection. I'm going to commit that. probably gonna complain about something, is it? Yeah. Right. I pushed a branch if you are stuck on a projection. It's just not worth getting stuck there. Did anyone get a working solution? It's a hard one. I don't expect anyone to finish it on time. The abstractions that I wrote so far in the exercise, they kind of work for most use cases. I took the average just to show a more complicated one. The basic one is the one where we take the last temperature, right? This is a bit more complicated because it shows you like how to pump data in a database instead. So let's actually I'm gonna start writing this because I see that a lot of people are stuck and we still have a couple of exercises that are still quite complicated. And this is misjudgment on my side. I probably overshot what we are supposed to do in 4 hours. I mean, if these were Jira tickets, frankly, like we are doing really good. Okay, so effectively what we can do is we can write a projection, and I'm going to write a new class, projection slash project average temperatures. And I'm just gonna copy over some details because I'm lazy. So this is under projection, and the body completely goes away because this is a completely different thing. Implements projection definition. So this is not an event sourcing concept. This is a thing that I built to make work a bit easier when dealing with projections. So effectively I do this. We return what was the table name? We added it here, right? Return, this is the table name, and from the scheduled operations We want to work on the temperature recorded. This returns a function. It receives the event. It receives a, what was it? I don't remember the interface on top. The projection table and a connection, right? And the connection returns void. And here we need to do some work, right? So this is kind of like how I like to do projectors, but it's absolutely not necessarily the way. You saw a for each loop works good enough. It's just that when you start having hundreds of little tables, you want to have a bit more manageable way of dealing with it. So effectively what we want to do is we want to make sure, sorry, this bothers me, it needs to be static. It needs to first of all make sure that there is a record for the current temperature. So we can work on the table and do an insert ignore, and we say event location. And what else? What else do we need to insert? Well, location is the primary key, so if we have a conflict, we're going to get an ignore, right? But then we have a few other fields. Let me split this. So we have even less screen space. We have the accumulated temperature. We start from 0. We have the recording count. We start from 0. And we have the average temperature. And we start from 0 to, right? And now what we want to do is we want to compute the average temperature. So we want to add the data from the current record. So we say connection, execute statement. And now we need to run some SQL. Because the world is not perfect and you need to run SQL sometimes. Sometimes you don't have fancy data structures to help you. So we are going to say update, what's this table name? This guy. And we're going to say set accumulated temperature equals accumulated temperature plus temperature. And we are going to set the recordings count equals recording count plus 1. And we're going to say the average temperature, I don't know if this works by the way, is equal accumulated temperature divided by recordings count. I don't know if this will execute with 0 or with the recordings plus 1. I think it will execute with 0, so let's actually do plus 1. Let's try this. I don't know if it works. And we need to say where the location is equal location, right? And now we pass in the rest of the parameters. So I'm just trying to keep the definition on the left, just have an idea of what we're operating on. And here we say temperature is the event temperature, Celsius, and the location. In theory, oh, this is wrong. Accumulated temperature is equal accumulated temperature. That's not a table name. Let's try it. I have no idea if this works. So now we have a definition. We have a migration. We need to glue it together. I'm going to copy this name. And we're going back to the exercise file. Whoops. It's fine. Bottle died. I hope it was just a bottle, not a laptop or something. Right, so that's the idea. So we have this helper. If we go back to the projection definition, this helper, this box down here, this entire thing up here, is this guy here. And this guy is nothing particularly fancy. What it will do is it will take a definition and then do some fancy iteration and look for all the operations that you can do on a projection and run them. In a more advanced system, it would do things like, for example, only iterate over the events that we want, because in an event store, you could have 20 million events and only 5 events that you care about. So it could be a bit more intelligent, but this is for a workshop. So practically I wrote implementations of this that are like 300 lines long and very well tested because complicated. But again, you can also use Kafka, you can use other systems, you can stream the information elsewhere and use a different processing system. You don't need to use PHP for this. PHP is quite slow at this. So, run it and see it fail, because this is a workshop and it will fail right now. Okay, I'm gonna just make a acceptance, run a make quality assurance first, and it will certainly complain about something somewhere, because it will say that I forgot some annotations somewhere. Yes. So it's complaining here. So this is a normal. Okay, this is immutable. That's fine. It needs to be mutable, but this is a different one. This says it's a more specific return type. So what we did return. Well, we declared that it needs to be a list of callables that accept a map from class name to accept an event. Right? It needs to accept an event, then it needs to accept the projection table, then it needs to accept the connection, and it needs to return void. And the problem is that we give it we defined event, but then we implemented an implementation that only accepts temperature recorded, right? So this is a more specific callable. If you give it a generic event, it will crash. And this is okay, and this is one of those rough edges where Psalm doesn't have a structure for defining something like this yet. But what I did is, in another implementation, I just said, if you pardon my French, fuck it, I don't care. And I pretty much just told it to shut up and just let me do my ugly things in this case. It's terrible, but it works. So I told it to suppress those statements, and right, and effectively I told it to continue this way. Last thing it needed is an immutability annotation. If you are wondering about the immutability annotations, and Marco, why are you wasting so much time on this stuff, it's because immutability is a super powerful tool. Once you start using it for good, you start seeing which things are going to break in production because they behave slightly different versus which things always work the same way. Everything that is immutable, you know, it always works the same exact way in every system. Everything that is not immutable depends a bit on the environment, and it can break again. Right, running it again, it will probably complain about CS, but we don't care about that for now. That's more of my problem for, right, that's fine. Right, so now I'm gonna run the exercise. Example, exercises, exercise 03, I think it is. Project average temperatures. Right, it did run something. So what I want to see is, in the database, I want to see average temperatures. The accumulated temperature is there, the count is there, and the average is there. So now I'm gonna add a temperature to the balcony. I'm gonna add 20 degrees to the balcony. Right? So we have exercise 1 to add temperatures. (20 degrees, right? And I'm running the projector again, and I want to see the temperature changed here. Right? It went down. It seems working, right? Maybe it's not the most intelligent, most useful system, but it shows you that you can effectively pump data into a projection system and continue from there. So far so good? Is this understandable what we've done? I know it is a bit fiddly, right? We had to use some of these abstractions. We had to write a bit of connection stuff. Then like write some raw SQL. Anybody write SQL like this still? Or everyone using an ORM right now? I think everyone is using Doctrine and forgetting about it. Yeah, well, Surgeon. Okay, so this was projections. So projections are effectively just pumping data from one system to another. And I'm trying to figure out, is this the documentation? Right. And what our projector does, and I tried documenting it, is that there's this projection runner. It tries to record which projectors are running, and then goes to the event stream, fetches the events. For every event, it goes to the projection definition, and the projection definition then pushes data to another system. Like in this case, the database, the projection database table, that's the other system. But this could be a file. If you have a website with a lot of visitors, for example, like a lot of visitors, then what you could do is that the projector is not pushing to a database, but for example, is pre-populating a file or a URL, a resource in Varnish. Anybody know Varnish cache or Squid cache, right? Instead of having Squid go to your backend system and query and then cache it, why not you going to Squid and pre-populating the data as soon as you have it, right? Whoops, there we go. Actually happened. Right. It happened. Better than stepping on it. Better than stepping on it. Right. So this could be like a caching system, a very high throughput system, and now you don't need to go to the database when your customers are coming to your website. I know the internet is for porn, so you imagine like the count could be that one, or YouTube or whatever. I know porn is what runs the internet. And that's actually where the entire stuff comes from, this entire Varnish cache and Squid cache, by the way, so just so you know. Right, so, yeah. Yes. So this structure then is where you read from. So the read model is a data structure that you can then use to either show things to the user, but going back actually to the Mira board, right? It's this guy here, right? We've been doing this for a while now. We've done it in 2 exercises already. This is our event store, and this is our read model. This is our average temperatures at every location. Because even in a real database, you don't want to group by and accumulate all the data over millions of data points. You can do it, it's just stupid to do it live all the time, right? It's wasteful. Databases can do it, but most of the time it's wasteful. Okay, so next comes the next concept. The next concept we are going to look at is another very powerful thing of event sourcing, because when you have an event, you know something happened. Now, of course, you can produce data from it, but you can also react to it. A user registered, send an email. A payment is nearing, you know, like a deadline, send a notification. So what we are going to do is we are going to react to events and produce the same thing that we do in Symfony and other systems with a listener, but with a more formal way. So in Symfony and in frameworks, in Drupal, in Zen framework, and whatever, you have this event system that fires an event, and then multiple systems attach to it and do other things. Those are called hooks. And sadly, the name event dispatcher, event system is kind of lost because it was abused for so many years, and now when you say event-driven architecture inside a single application, you don't usually think of event sourcing. You think of, I fire an event and some services attached to that event do some work and maybe modify the running system. And that's sad, but that's the state of affairs. So in event sourcing, what we say is we have a process manager which takes whatever happened and starts new processes. So we had to kind of like figure out a different name just to distinguish it. So where is it? Down here. So what we've done in this particular project is that we've defined a concept of policies. So a policy is, when this happened, make this happen. If this, then that. You know, turn on the light when the door was opened. So you can react to an event, and you can write a policy. And I'm gonna show you a policy. This is what a policy looks like. So a policy is an interface that is specialized on a specific handle domain event. So this is a template parameter. So when you give it that event, it will produce a list of commands to execute as a reaction to that command, to that event. And then I just added a method to be able to get the name of the class at runtime, just so that you don't need to get confused by it. So this is what a policy looks like. And so if it's an if this then that. So what you can do is you have an event store, and in the event store you have door opened and door locked, for example. You have multiple policies, right? And you say when the door locked, then turn off the lights, right? So turn off the light. And that in turn produces another event, which is the lights got turned off. And then when you can say when the lights turned off, do another thing. So it's kind of like, anybody play Factorio? No? Really? Nobody plays Factorio? Oh my god. Is this one? Did anyone actually play this at least? Oh my god. What, you don't know shapes? Shapes, you know? Oh, you pretend you don't know Factorio. Anyway, Factorio is a very addicting game. It's a like to heroin. Don't start. It's terrible. You start and suddenly, it's like Reddit, you know? You start with the pictures and suddenly 2 days have passed and the weekend is gone. Anyway, the idea of a policy is effectively that you are taking your factory, your event store is the stuff that comes out of a machine, you put it on a conveyor belt and you put it in another machine. That's what a policy is, okay? That's kind of the idea. So the other machine is apply the policies, and the policies will produce new commands. Now, we didn't talk about commands that much today, and we're probably not going to use them that much. But if you ever use the Symfony Messenger or a command bus in general, or you're seeing a command messenger anywhere, it's a very powerful abstraction that allows you to like pipe data through your system and make sure that execution is safe. So we implemented a process manager. I will spare you the details on that, but it's documented here if you want to see how it works. But what we want to do is go to exercise 4, and we want to send an alert to someone when the temperature is below 0. So when we record a temperature that is below freezing point, right, we want to create a new policy. A policy is an implementation of the policy class. So you can look at existing policies in this project. There should be 1 or 2. Then we want to create a send temperature below 0 alert command. A command is nothing fancy. A command is just an empty interface. There's nothing to do on it, right? The only thing a command needs to do is to be immutable. And we want to create a handler for that command. That's a bit more tricky. A command handler is a class like this. It has a method for doing something and a method for telling what commands are compatible with me. And we have to just produce an error log message from that command handler. And then at the end here, we say something like new process policies with some parameters and call it. Right? This is what we want to do. So if the temperature goes below 0, we want to send an alert. Like, for example, the cellar is below 0. Okay? Or the temperature is above 35 in the wine cellar and you can throw away all the wine. You know? You don't want to do that in a restaurant. Really expensive mistake. I'm going to prepare the commits from the previous branch meanwhile. If you have any questions or anything, let me know. We're starting to have more moving parts, but a bit simpler ones. What do you want from me here? Okay. Oh yeah, good point. I committed it, right? Okay. Relatively plain. Is this working? It seems to be working. Okay.
You had this
Okay, yeah, the wiring part. So we have these process policies thing, right? So process policies, I don't remember the constructor arguments, so I always look them up. So it receives a list of policies, so new my policy. And then it receives a command bus. Oh, command bus is difficult. I forgot. Command bus. Where is it? Actually, let me go command bus. I built a command bus. This guy here. And it receives a list of commands. So this command handler. So new my command handler. And it receives the traverse event stream. So effectively, when we do these things in these scripts, this is where you would, like, for example, in a larger application, say, I have my dependency injection container, build it for me, and all my policies and all my command handlers and everything is part of it, right? Here we are doing it ad hoc to show the single components, but you just build the entire thing and put it together with, like, your 100 command handlers, 100 policies and whatnot. So this is a very brutal implementation of the command bus. So it just loops over stuff, and if it cannot find something that works, it will just crash. There are multiple command buses out there. You can pick any you like. Symfony Messenger is a good choice. Simple bus as well. PHP League has one, I think. I prefer writing my own because it's 20 lines of code max. Give you another 10 minutes. Has anybody got a working thing? Nice. Down here. Oops. Keep messing. Anyone else got their working? Nice. It's a bit simpler than the projections, I think. It's just more pieces, but it's a bit simpler than that. Does anybody actually know how to disable those Ubuntu pop-ups? Because I put it in do not disturb and it still disturbs every time. I don't know how. Right, I am going to start writing some commands because we have roughly half an hour, and then comes the most hard exercise. And I'm not planning to finish that. I'm just planning to show you how it works, kinda, and discussing it, and then leaving it to you, like you decide whether to continue. And another thing is, if you're stuck on something, or you're like, Marco, I was on your workshop and I have no idea how to continue on this, or I did not understand why this doesn't work, send me a pull request with your branch and we review it together, and I'll try helping you out. Right? I'll probably close the pull request, but we continue discussing in it because it's going to be interesting to see where we got stuck, improving both the workshop and your knowledge of the topic. So, right, so what I need to write is well, I need a command handler, and a policy. So I'm going to write a policy first, and it's going to be under the temperature tracking, under domain, and I'm going to write this, and this is under namespace, Eventsourcing workshop, temperature tracking, domain. We implement when temperature below 0, send alert, implements a policy. Since this is a templated type, inheriting from a type that requires a template parameter, we need to say template implements policy, and we handle the event of type temperature recorded. And now we implement the methods from the interface. So this is just telling Psalm this policy belongs to this event type, kind of. So we say if event Celsius is smaller than 0, then something, otherwise we return an empty array. Actually, if greater than 0, then return an empty array. I like having the success path of a function at the end, and every fun out scenario be an unhappy path, like it's not going where I'm supposed to go. So to do and to do. We don't have the command yet. So now I'm going to write the command. So this is under command. And let's implement this class. Let's copy everything. Implements command. So, oh, this is the wrong class name. Okay. So a command is the same thing, it's just Psalm immutable. It doesn't perform any operations. Another thing why I use immutable so much is that, especially at the interface level, I force you to have an immutable implementation. So I define an interface like a policy. I think policies are immutable. I should have made them immutable. Right? They are immutable. So the child class also needs to be immutable, which means that inside invoke you cannot talk to a database. You cannot read a file. This is by design. The policy should take a decision here without talking to the external world. It only receives the event as contextual information. Everything else is unknown to the policy, and that's really a strong part of the immutability definition. So, public function construct, and here we receive a public read-only string location and public read-only what is that, float temperature. This is Celsius. Let's use Celsius again to avoid confusion. Sometimes use Psalm param, sometimes param. I'm still very confused about it because meanwhile both the PHP Storm and the rest of the ecosystem has caught up, and the Psalm prefix is not needed on a lot of stuff. So if the temperature goes below 0, then we return we return a new send temperature below 0 alert. And the location is the event location, and the temperature is event Celsius. So this is going to be a lot of scenarios you're going to have this where you see that pretty much you're putting the entire event into the command. Happens a lot. It's not a problem. You could also even put the entire event if you wanted, but that's your choice, right? I prefer just putting what I need. Maybe the event grows in size and I don't need the rest of the event. Send temperature below 0 alert class is what we return here. Okay. Oh yeah, sorry. Good call. Thank you. Good call.
You said that we can put an events. Okay, I thought about versioning and if something changed with the event, but it doesn't change anything because it will not be stored in database anyway. So
no, it doesn't matter. Commands are much more chill. You can change them and redeploy. The only thing that can happen in a command is that, let's say that a command goes to a bus, and the bus is asynchronous, so you store it somewhere, you do a deployment, the command definition changes. Now when deserializing from the bus, like a RabbitMQ, right? You put a command on RabbitMQ, you do a deployment, now you read from RabbitMQ and it doesn't match up anymore. That can happen, but it's rare. And it's kind of like the same problem that you have with sessions in PHP, right? You change your software, you redeploy, and now you need to decide, do I need to destroy all the sessions for my users because something changed in my session? Kind of like the same thing. But it's not as disastrous as I can't load data from my database anymore, right? It's not as bad. Okay, and now I need a command handler to wire it all together, right? Because now I have my policy, which is when temperature blah 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 below 0 send alert. That's my policy. But I need my command handler here. So that's under infrastructure. I'm just going to write a class here, command handler, and we're going to call it handle send temperature temperature below 0 alert.php. Right, copying stuff because I'm lazy again. Command handler. And this is implements command handler. Now this is one of the rare classes where it's not immutable, because effectively a command handler can do work. It can talk to the outside world. So it handles the command, what is it? Send temperature below 0 alert class. And here it says error log temperature below 0 recorded in, I don't know, the command location. And we also put the temperature. Something like this. That's pretty much the thing. And now we take this command and we put it in our wiring. This is what I would put under the glue code. You saw I even have a glue namespace, right? For me, the kernel, everything that is like Symfony dependency injection, that's what I call glue. Because it's, you know, like when you do a project and then you just put epoxy to put everything together, or like just hot glue because you don't care. That's exactly what this is. So when you need to change the project, you need to throw away that part and do it again. So removing everything here. So we've done the command, the policy. We've written the command. We've written the command handler. We wired it all together, and now we need to run it. So now I'm going to run it first. Let's actually exercises, exercise 04. Right, it runs without problem. Okay, exited with 0. So we need to record the temperature, right? Balcony, -10. And now we run it again. Ooh, there's a crash. Class not found. Send temperature. Oh, I wrote the wrong class name somewhere, right? Send temperate. Send temperate. What? Send temperate? Why? What? Okay, this is gonna be a mess because now it's gonna complain I can't get there. What did I do wrong? Anybody notice that? Besides the class name? Oh, right. Well, this is okay. Oh, it's in the wrong place, is it? Yeah. There we go. Should be under domain. Let's try again. There we go. Undefined property. Oh, it's not temperature, it's Celsius. Of course. This bites me as well. My mistakes. Need to suck them up and deal with them. Right, so it says temperature below 0 recorded in balcony. I'm now going to add -10, -20, -30. We're starting to get really cold, and if I run it again, it runs it for all of them, okay? And if I run it again, it does nothing. This is important. While the projections are designed so that you can rerun them as many times as you want, this could be like a late payment notification, right? So if you have a customer and they pay you and whatever, some customers get a late payment notification, and you rerun policies after 1 year, you're gonna send emails for late payment notifications for things that people have already paid, or resend registration emails, or resend marketing emails. Don't want that, okay? So the policies compared to projections are run only once, okay? So once you have a crash here, how you recover depends on you. It is very different from a projection. Projection, you can rerun them as many times as you want. Policies only once, otherwise you're in big, big trouble. So this is where you have that cursor, and in this case, the cursor should never be reset. If you reset the cursor, you're in for a lot of trouble, okay? And if you have a new policy and you deploy it, that policy should not apply to old stuff. It only applies from the moment it goes live, okay? So even if it is a new policy and it gets mixed with everything else, it only applies the moment you turn it on, not to old stuff. It's kind of like the law. It's not retroactive, right? You don't get fined for stuff that is now illegal, but wasn't illegal a year ago. In theory. Depends on where you live. Okay, so the idea behind this is effectively that we now have a mechanism for doing automation. You can do home automation, you can do process automation, you can do this in an e-commerce system. Shopping cart purchased, payment requested, payment completed, shipment initiated, right? This is kind of what you can do with a system like this. It's a kind of like a machine that feeds itself. And this is very powerful, and it certainly is less complex than dealing with the traditional like event system in memory, where you cannot track who caused what. Because now you have a very, very clear track of which event, which command, which event, which command, and you can add a little tiny logger, for example, for commands to just say this command got fired because of this event. And if you do that, you can have full traceability of what caused what. Okay, so last topic for today. I promise then we're done. So there is one last thing in event sourcing which is a bit more complicated. So we talked about domain events and we talked about policies and projections. But then what happens if you have something more complicated, like a process? So here's, for example, a process that I really like because it makes a nice diagram. This is a door. A door goes from an unlocked state, it can go to locked state. From a locked state, it can only go to an unlocked state. From an unlocked state, it can go to opened, but it cannot go to locked from an open state, right? And then from an open state, it can go to closed, and from closed, it can go to open. But from open, it cannot go to locked, right? It needs to be first closed, then locked. So this is a bit of a state machine. This is a state machine like you see them in universities usually, right? What is interesting is that the state is where am I? And the transitions are the events, okay? So you can have that for a door. You can have it for a shopping cart. Shopping cart starts from an empty cart. You add an item, you have a non-empty cart. You remove an item, you could go to an empty cart, or you can go back to a non-empty cart. Depends on how many items you have. And you go to a checkout, and the checkout is the last state. After a checkout, you can no longer touch that cart. It's gone, right? So you need a new shopping cart. So this works for a shopping cart. It works for a bowling match. Bowling match, you have a throw. The match is in process. You can throw balls as much as the game is still going on. That's the only thing you can do in a bowling game is throw a ball, right? And the only thing that can happen is that the match is over. But effectively, the game decides for you when the game is over. It depends on how many strikes, how many spares, how many times you throw the ball just on the side. That's up to the game. So this is what you would say, well, it's a state machine. And you can build very complicated things, very complicated systems for state machines. Like there's an entire symphony component for it, which I believe is totally overblown and super complicated. Whereas these things should be what we write in code and maintain and test, not write it in a different language that then gets transpiled to PHP somehow and magically becomes what we want it to be. So an aggregate in an event source system is, well, it's one of these, right? It's a state machine. But if you look inside it, it's just a stack of events. It's the history of that specific aggregate. So in this particular system, we have, well, domain events you've seen, but then we have aggregate domain events. And an aggregate domain event is a subclass of a domain event, but it also is associated to a certain aggregate. So it says, I am an event for this bowling match. I am an event for this shopping cart. That's what an aggregate domain event is. It's just one added field to the domain event. And you may have seen it in the database. In the event stream, we have a bunch of columns for aggregate stuff, and they were null, right? That's literally all this is about. So, when we save an aggregate, so we obtain an aggregate from history. So let's see. Right. So you can build the aggregate from its history. So you give it a list of its events, and it will put together the final state, kind of like a door: open door, closed door, open door, closed door, open door, closed door, lock. And that's the list of events. So what state are we in? The door is locked. That's the work of the aggregate. It has to go through all the events and figure out where are we, and that's aggregate from history. It's a single static method on your aggregate. And then otherwise you can also create an aggregate, do something on it, and save the results. So like we are locking the door. We save the result of locking the door. And what's interesting is that compared to, for example, doctrine entities, you're not saving the door. You're saving the fact that you locked the door. Locking the door produced some events, and we save that. So, let's go to the aggregate. Did I actually link it? Yes. So this is what an aggregate has as an interface. We have this guy again, ever-present aggregate, immutability. So an aggregate is an immutable piece of logic. It's just a state machine. It just takes decisions. It doesn't talk to the outside world. It takes from its state, and it moves you to the next state internally. And you can reconstruct one from its history. So that's the only required interface implementation. It has a static constructor that you can build it from a history, given its ID and giving a non-empty list of events. So an empty list means that it doesn't exist. It must be a non-empty list for it to exist. Okay? So, this is what an aggregate is. Let's look at an implementation. This is a greeting, for example. This is a hello, goodbye. Hello, goodbye. It's a stupid implementation, but it's good enough for showing how this works. So when we say hello, we initiate a greeting or initiate a meeting, for example. This could be like, instead of a greeting, it could be a meeting, right? A meeting starts with hello and ends with goodbye. It's a very good idea to have aggregates as a thing that starts and ends, because if you have an aggregate that is a very long process, that is like thousands of years long, it could become growing. It could become infinitely large, right? It's good to have it small, like a shopping cart, like a product in your e-commerce maybe could be an aggregate. But if you change prices 20 times a day, maybe not so good idea to have the product as an aggregate. Okay, so you say hello and you create a greeting, and then you save, you return this aggregate changed, which says this is what I produced during this interaction. So what is interesting is that what you return to the caller is not the object. You return just the list of things that happened. Hello was said. And goodbye, say goodbye is the opposite. We say like, if I already said goodbye, then disallowed interaction. I don't know why I keep right-clicking. So if I already said goodbye, then make it fail. This should not be possible. We already said goodbye. The meeting's over. Why are you saying goodbye again? And then otherwise produce a goodbye. And in from history, you see we iterate over the history, and we produce a list of events. Or sorry, we produce the internal state of the aggregate. Okay. So, in exercise 5, I produced a number of files because it's not so simple. There's much more happening. So we have requesting a payment. So let's say that we have an aggregate which is representing a payment. Somebody wants to initiate a payment, therefore we start the payment aggregate with a certain amount of money and a deadline. And then we have a system to inject time events. So we have, where is it? Record day passed. This is just an inject time script. So when you run it, it will just say a day has passed. So this is something you would put, for example, in a cron job. Every midnight you run this, and it will inject in your event store that midnight has passed, that one day has passed. And you can attach policies, and through the policies you can look at all the pending payments and go through them and send notifications to all people that haven't paid yet. And then we have a payment received, which is closing the interaction. So we take the aggregate, we say payment was completed, and therefore we don't need to pay up anymore, and we don't have that as a problem anymore. So I'm going to implement first just the request payment and record payment created, payment received. We don't need the projections. We already done enough projections for today. I think we're okay with that, okay? I probably overshot with what we can do. So what I'm going to do is I am going to create a new payment aggregate. So I'm going to say payment equals payment request payment. We have to give a debtor email. This is something I'm writing because we have 20 minutes, so I want to leave 10 minutes for questions, just so you know, or chilling, you know. Okay, so we have a debtor, we have an email address and an amount. So we are going to say new debtor email with the email address and a new amount with the amount. And the time, which is coming from the clock, kernel clock. No? Why? Oh, it's obviously because of the exception. By the way, I'm already super happy if you start using things like PSL, the clock, and all the kind of little tricks we discussed today. Even if you don't learn event sourcing, I hope you've seen very different PSP code from the usual today. What is payment? Well, payment is now an instance of this aggregate changed. So the payment aggregate has two methods. One is for requesting a payment, and one is for paying up. And then from history, which is the one from the interface. So requesting a payment produces an aggregate change. So this means that we're just raising an event. Actually, we're raising two events. We're requesting that a payment, and we're setting a deadline for the payment. I discussed it with someone in the back, but when you have events with lots of fields, it's a good idea to make different events so that you can deprecate and phase out single events in a bit more simple way, right? So you could say, for example, instead of having the debtor here, you could say new payment debtor identified. That could be a different event, right? Just keep your events small because it's really hard to change them. So the more fields you have, the harder it becomes to keep stability in the system. If you have an event with 20 fields, rest assured, in 2 weeks, somebody is going to tell you to add a checkbox somewhere, and you will have to add a new field to an event. And that's not fun when that happens. Right, so we request the payment, and now we say, well, I'm going to say kernel, I want an aggregate repository for the payments, and I want to save this payment. And let's actually try it out and see what it does. So, going back to my scripts, example, exercise. I keep saying example. 05, and what's the script here? 02. Request payment. Unexpected token. I forgot a semicolon. I'm good at PHP. So we need to give it an email address and a positive int. So my name, and then I will give it €100 is what I owe these people. So when I go to my database now and I look at my event stream, what is interesting is that I now have a couple events. Let me transpose this again and go to the very end. So I have a payment requested, and it tells me also I am associated to an aggregate of type payment. So the aggregate repository knows how to load it. This is the ID of that payment, and I'm at version 1. What is that version? So the problem is when two people interact on the same aggregate at the same time. So in this case we have two events, one is version 1, one is version 2, because we produce two events on that aggregate. Well, we have two problems. One is they need to be sequential inside an aggregate. We need to guarantee their sequence number. You cannot rely just on the storage. And the second thing is, on a single shopping cart, let's say that two HTTP requests come in at the same exact time. You have a very, very high concurrency scenario where two requests come in at the very exact time. Which one is going to win? You don't know. So what we did is we introduced optimistic locking this way, which means that if two requests come in, both requests will attempt, let's say, to insert an event with version 2 for the shopping cart. One of the two will fail. That's what the version is for. It guarantees high consistency because the aggregate is a state machine, and you cannot afford having two parallel processes moving the state machine at the same time, because you would end up in an inconsistent state otherwise. So this is what in database design is usually called optimistic locking, which basically means I'm going to throw some data at you hoping that it works okay by adding a version. And if there's a collision on that version, we're going to have a rejected insert operation. So this is effectively the same thing you saw before, except we have another 3 fields. That's it, right? It's nothing special. We just associated an event with a specific identifier. So what we obtain by doing this is we have kind of the same thing that we have in Doctrine, where we have entities. You know, you get an entity from the repository, you modify it, and you push it back to the repository. And we do the same thing here. So let me implement when a payment is received. So what I'm going to do is I'm going to say, I'm going to take the repository kernel. Let me close a few things just to show you what's going on. Kernel, I'm going to get the aggregate repository for payment. And I'm going to get, what is it? New payment ID. We want to fetch by payment ID, and the ID is given by the parameters. Right? I use the same trick in every script. And I'm going to say pay an amount. Do I have other parameters? And I have to give it the kernel clock. The time, not the clock. This is producing the change. So I'm going to like say kernel aggregate repository payment. Bear with me. Sorry, I'm also like spacing out a bit. So this is kind of like how it works. 90% of the cases, let me write it so that we don't need to redo this all the time. Repository is equal this. And now we say repository save and repository get. Okay, yep.
Two versions of the aggregate.
We produce two events.
That's clear, but why? I mean,
Right.
Why do two events need two versions of the aggregate?
Right, okay, so the events are basically the version guarantees that not two processes in two different machines come in at the same time.
It was one process.
Oh, yeah. Okay, so the version is version 1 at this event,
okay,
and version 2 at this event. That's what happens. Right, there is a unique key on the version, and let me actually show you. There is a unique key on the database. All right,
I guess what I'm asking is why didn't the aggregate update at once for both events?
Yeah. No, that's just because of how the storage works. It's really a storage problem, and I want to see the SQL scripts. SQL generator. How do I get the DDL here? I don't remember. Modify table. Well, on modify table, I get the DDL, and it's a really janky and tiny UI for a presentation. But there is a unique index. Aggregate root ID, aggregate root version. So hard to read from the back, but aggregate root ID, aggregate root version is unique. And this is kind of like the optimistic locking mechanism that I told you about. Another way to do this without involving optimistic locking would be to do pessimistic locking. In pessimistic locking, what you do is you say, okay, when I get an aggregate, I'm going to create a database lock and prevent anyone else from reading or writing to that aggregate while I'm touching it. And when I save it back, I'm going to release that lock. So in that case, you remove the field from the database, you remove the problem of having the unique key, but you introduce runtime locks. And those are also not necessarily fun to debug. So it's just two different strategies, but you need some sort of locking on aggregates, because otherwise you may have the state machine moving and saving inconsistent data. Because literally that's the only job of the aggregate, maintaining consistency. While the temperature being recorded may come from external sensors and you have no control over it, here it's about keeping things under control. So in one system, we are like just tracking data, we're just recording it, we don't care if it's right or wrong, we just record it. In this one, we're a bit more of a control freak, and we try to keep it under control and make sure that it's highly consistent. But what I wanted to highlight here is that this kind of design is not far from what we do in Doctrine, right? It's kind of like get from the repository, do something, flush, right? And we do the same here. We like get something from the repository, do something on it, but we save the result of that operation. And yeah, this get operation under the hood, it just is a very glorified, where is it? Down here, there is a from, well, it loads from history, yeah. It's a very glorified from history with a lot of type annotations that I had to add because, of course, we're transforming strings to objects, and it's really hard to teach PHP how to do it in a type-safe way. So that is kind of the idea. So now when I say pay, where is it? I want 3. Payment received. Well, now I need a couple information more, because now I need the ID of the payment. So I need to copy it out of the database. That's something that we would use a projection for getting the list of payments, for example. And I would say 100. And I go back to my database. It should have, there it is, version 3. Version 3, because we have a payment completed. What's the name here? No, that's the aggregate name, and this is payment completed, right? And inside the aggregate, you can add logic. So for example, in this particular pay interaction, I can also say, like, what if I already paid? What should I do? What if the amount is not the correct one? What should I do? I have left it all open because I want to show effectively how you can write logic for this. This is where you write the business logic for this stuff. And you write the tests for these aggregates as well. So like, what happens if I remove a shopping cart item that does not exist? Do I want an exception? Do I want nothing? Do I want some particular event, like a different event? What happens if an item goes out of stock? Do I record it in a shopping cart as an event so I tell the user about it specifically that the item went out of stock and therefore it was removed? So you can go much more detailed than traditional business logic in here. So that is kind of like the idea behind aggregates. And yes, that would have been a very long and problematic exercise to do at this point. Probably the rest of the 4 hours would have gone into that. But I wanted to show you that because, yes, we've spent so much time on policies, on projections, on like literally, oh, but why are you showing me this stuff? I can do it with, I don't know, Grafana, you know? Why are you showing me temperature tracking when I can do it with Grafana? I wanted to also show you that you can abstract business logic with it. And another thing that is nice is that when you write tests for these systems, and let's say that we go back to the definition of aggregates, down here. So let's say that you go in here, like the definition of these jumps, these hopping around the entire state machine, you can write this with Gherkin. So you can say, given an item was added to the car and the item was removed from the car, then the cart should be empty, right? Something like that. So you can kind of write the logic. You can also say, like, when given an item was added to the cart, when I check out, then this happened. Okay, so there is a very little impedance between the Gherkin language and event sourcing. So you can write much better specifications when a feature request comes in. But in practice, auditing, a lot of performance because the entire like writing very specialized data structure is very powerful, and hopefully like a better way to approach software development and complex software development in general. So, yeah.
That would do its job. The aggregate should store the last event that it was created from.
It doesn't need to store the last event. The ID, yes. The ID for sure. In my implementation, I gave the ID as one of the parameters. So it's here. At least that is part of it.
No, I mean, so when you load the aggregate from the database, in order for not to use the entire history, but only the history that was created, for example, from the last time.
Oh, yes. Let's say that you have 1 million events, and you load an aggregate with 1 million events. You don't need to redo it every time. Since we already loaded it, you could use a cache or something and save just the last state if you wanted, right? So you don't need to store the entire history. You could also like start from the last version of the aggregate.
Exactly, yeah.
This is called snapshotting, but it's really, you will not need it. Like these things up to like 10,000 events, not a problem. It's fine. Okay. Don't worry about it. Okay, so look, we have 2 minutes, and I don't want you to be the last in the queue for lunch, okay? So if you want to go for lunch, fine. If you want to catch me, just tweet me on Twitter. We'll catch up around the conference. And if you have any questions, send per request. I'm super happy about that. Thank you.